afternoon, good evening, depending on where you are. Welcome everyone from my behalf to Skill Me Up Expert Talk, first of 4 Azure Security talks that I will be presenting. The topic of this session is Azure Security Foundations. Couple of brief words from myself. My name is Karl Ots. I'm an Azure MVP, Microsoft Regional Director, and CISSP. I have a long history with cloud and cybersecurity. I've been working with Azure almost a decade now, and currently I'm working in a Swiss financial institute as an in-house Azure expert, but I've had different hats and different roles all across the board. A very good note from the audience, thank you. This wasn't really the important slide yet, as this is only just about myself. I hope you are now able to see my slide and not my presenter view. Thank you. Excellent. So yes, I have a decade of Azure expertise. I specialize on Azure security. And in my previous life as a consultant, I saw all sizes and all different types of approaches to Azure. Right now, I'm focused on an enterprise point of view to Azure security, but I've helped secure and assess over 100 different Azure applications from small or starting small startups all the way to the largest enterprises there are. The webinar is being recorded. I believe that the slides will not be available, but the whole recording will be. So today we are going to cover quite a bit of different topics. This will be quite action-packed session, lots of materials. I will also provide you lots of materials to learn more, not just on this foundation, but also during the next Azure expert talks I will be giving myself as well. So we'll start off with an overview of Azure threats, maybe some new ones. Hopefully, if you consider yourself as a security expert coming from on-premises or other cloud worlds, you'll see some new ones that evolve in Azure specifically. We'll consider some of the roles and responsibilities between us and the cloud provider, in our case, Azure. Then we'll move over to a series of the key controls that we have available for us in Azure Security Toolkit. We'll talk about identity, both authentication and access control in more detail. We'll talk about data protection, and finally, have a look at the built-in monitoring capabilities that is slightly different from what we might have been used to. With that, feel free to ask questions throughout my different topics here as well. At the very latest, I will go through all of these questions at the end of the session. The session itself is roughly 45 minutes, and you can spend up to 15 minutes in the end I can spend my time to answer your questions at that time. All right, and let's really do some level setting here for the conversation here. So let's start to look at the typical ways organizations look at adopting cloud. So typical cloud adoption strategies, and this is what Microsoft is promoting as well. And this might be something that you are looking at. This might be slightly different, but this is something that I see a lot of organizations have at least some variation of this approach. So first of all, for any or all applications, when they run into application renewals, they really start to prefer software as a service, to really go for these evergreen solutions for any type of commodity workloads that might not bring any competitive advantage to them. But new application development, specifically the applications that do bring competitive advantage towards against the competition, those typically I see is targeted or are targeted towards platform as a service, really native or cloud native specifically capabilities. So we'll see modern application development, we'll see all sorts of API management, orchestration, CQRS, and we see all types of new environments, new functionality in the whole Azure toolset. And that means that there's lots of power and lots of new responsibility that's shifted towards the developers. But this really is the kind of crown jewel for any type of new and groundbreaking application in the cloud. So a lot of business will see focus on that side. And then lastly, of course, we have the migration of the existing workloads to infrastructure as a service. Now, depending on your region, it might be that simply moving away from an on-premises data center that you would run and manage on your own, already that will bring you a lot of business benefits. But in a lot of cases, this is only an enabler, only one small piece. And for a lot of your applications, you would actually want to look at how to convert your existing virtual machine-based applications into platform as a service as well. Some level of refactor, replatform, re-architect. And with this approach, we have some security practices that will stay the same throughout all of these different infrastructure as a service, platform as a service, and software as a service. First of all, very similarly, if you have any sort of application level risks, if you have any sort of threats within your actual application, most often the applications that are hosted in the cloud are web applications. Those are still the same. We still have everything that we had to worry about exploiting past the hash attacks. We have the same approach in infrastructure as a service of misconfigurations in the OS level. We have all of the responsibilities of patching and hardening our environments. And we really have this shift towards this zero trust approach, where multi-factor authentication is not really just an additional bonus for really high privileged users, but it really could be something that we tightly build into our day-to-day operation, into regular developers, maybe even regular application end users as well. And as everything is actually software defined, we will see actually the amount of security events and the amount of information and logs actually exponentially grow. So we will need to have some way of actually navigate through that noise. We will need to have some way of maybe parsing those through some pre-configured automation or even quote unquote artificial intelligence as well. And finally, we'll have massive amount of new capabilities that are native to Azure. We have capabilities that let us scale. We have functionalities such as Azure Policy that let us observe our existing Azure infrastructure and application environment without going in and evaluating each of them manually. We have even ways of mitigating those automatically through Security Center. We might end up building our own sets of policies on top of any of those technologies, or we might use some new level of abstraction that is slightly safer from exploitation, mainly in the functions as a service abstraction layer. And in the end, all of these really drill down into this matrix of shared responsibilities and shared risk. As we lift our operations and we lift our trust in security towards a cloud provider, we give away the controls that we used to have for the physical, maybe even for the operating system, and maybe even for the middleware layers as well. if you look at software as a service, we only have essentially data governance and authentication and endpoint management controls available. We cannot go in and prove or make any changes in the way Microsoft is operating Office 365. We may choose from some of the options that are limited but available for us, maybe behind a paid service tier. But that's pretty much it. If we want more control, we'll need to go further down into the layers of abstraction, which means that we get better control, but we also get less integrated security, less security built out of the box. And we really should drill this approach into, first we should start by trusting but verifying each cloud provider where we go. In Microsoft case, this really means that we will actually go in and see where does Microsoft actually promise that they do certain things. Microsoft provides us Azure Service Trust Portal, where we can go ahead and after logging in, download the reports built by the third-party auditors, and even the reports for compliancy for a lot of those compliance toolkits. And if you are in certain fields such as medical or health or government, we also might get to have private webinars with said auditors, and we get all of this raw data available for us. But this is again slightly different from this colo type of approach where we could actually come in and audit what Microsoft does physically. That's not something that's available for us, just purely from scaling purposes. It's only one global auditor vendor that does that auditing, and then we get to consume the results from them. Next, for the infrastructure layer, and all the way up from there, infrastructure as a service, platform as a service, and software as a service. So for any of those workloads that require managing any of those infrastructure components, virtual machines, containers as a service, we really need to, or we really should take advantage of ways of automating patch management, ways of automating configuration management, and really this DevOps approach to the whole operation of the infrastructure. And lastly, we should, in the end, really establish our whole security perimeter, not across the network layer, because that's not available for us in software as a service and all platform as a service components. We should really establish that across some modern perimeters, such as device management or a combination of device, identity, and other information. And from Azure point of view, we still have the same level of threats that there used to be. As you saw, it doesn't really, as you saw last week, it doesn't really add value if you are in the cloud. If you are one of the highest on the terms of expertise in this cloud security side, you can still be prone to social engineering, especially if you are not treating your secrets as secrets. There's still phishing, ransomware, more and more, something that's existing, but maybe even more relevant now in the cloud era as everything is connected. And if you look at the new threats, some of these existing threats can become even higher in terms of the actual risk they pose to us, because we quite often connect our on-premises environment into the cloud. So you could traverse from on-premises to on-premises networks from maybe a little bit slightly differently managed cloud environments. In the cloud, if access is available on a more broader scale, then password spray is something that we might not even, if we don't control the whole network perimeter, we might not even notice that as we would in our existing environments. And denial of wallet being really this one of the top threats for serverless, essentially generating instead of generating denial of service with the auto scaling capabilities and unlimited capabilities to scale in the cloud world, we could really attack, or we could really see these attacks on actual actual costs of the cloud infrastructure. And finally, while the security compliance is an important topic, I really want to stress here that even if you tick all of the boxes and even if it looks like you are green in your chosen security or compliance framework, it doesn't really mean that you are actually lowering your business risk. It really should come from your understanding of what are the threats that are relevant in your business and what is acceptable risk appetite of your business here. And even if you have a very good way of automated compliance checks, even if you are checking against a specific set of categories like CIS or CSA and NIST, any of these frameworks, it doesn't mean that they are comprehensive, covering everything that's available for you given services, or it doesn't mean that they are covering the important parts from your business perspective. So every org is different. Anything that I might ramble on during the later parts of the course should be considered in the context of your own business. So let's get started with our first set of controls, which is really about this new perimeter that's available across software as a service, platform as a service, and even on the infrastructure as a service layer. So in Microsoft Azure, identity is key. Wherever we have any Azure environments, there's any credit card based or enterprise agreement based way of procuring Azure environments, we always access there through a centrally managed identity system. And a key thing to understand here is the concept of role-based access control in Azure. And role-based access control is a combination of this centralized identity, which is always there. Each Azure environment is always linked into one native Azure Active Directory tenant or organization. So we always have the capability to link into this centralized identity that's maybe even hosted, maybe even synchronized with our on-premises identity, but not necessarily. It can be very purposeful that we don't synchronize with Azure Active Directory from our own premises. Most often we want to, especially if you are already in software as a service, if you already are in Office 365. So Azure role-based access control governs access to do anything in Azure. It's how we grant any other authorization rules into our Azure development environments. And the authentication part is always outsourced to our Azure identity. There's always only one Azure Active Directory that we'll use. And in terms of a role-based access control assignment, so a single access grant, we always have one part of this combination of a role-based access control is an Azure AD identity. This can be an individual user, a group of users, an Azure AD group. This can be a service principal. This can be a system managed identity. This doesn't have to be a user, a physical human being. So authentication is handled with Azure AD. We might have our organization-specific multi-factor authentication rules in place. We might have any other risk management controls there. Then we have the scope or the target of our Azure role-based access control assignment. This can be a subscription. There can be other parts, but essentially this covers how wide will our access be for this given Azure AD identity. And finally, we have these roles. And the idea for these roles is that we would not have this access creep that when a user has been in for 10 years or so, they just constantly get added individual access. And if they leave, we don't really know what is the minimum required access that they will need. So the idea is that we have these pre-built sets of roles that we should assign to. In reality, most often we will have a combination of roles especially in this kind of DevOps approach. All of this together is a single role-based access control assignment in Azure. And specifically, I'm going to talk about these roles now in a little bit more detail, because there's lots of, not just misinformation, but let's say misconfigurations that I see related to these roles. The first role that we very typically see in Microsoft documentation from these built-in roles that Microsoft offers, that's in the top of the list in all UIs, after everything else is alphabetically, is the owner role. And the owner is a role that can do everything within your Azure environment. They control access management. They can invite anyone in, they can kick anyone out, and in most cases, they can even configure which organizations are actually trusted in that trusted Azure identity. They can go ahead and actually change the configurations in a way that you could actually invite not just your own organization users in, but also from a partner organization or anyone with an email address. And that's, of course, something quite scary. If you trust everything behind one single trusted identity management solution, and then someone comes in and might be able to change that. So that's pretty powerful role. And owner is the role that you will get when you create your own Azure subscription. This is the default role. And quite often what I see, if I go to different environments, I see that everyone is an owner because the second developer who came in just wanted the same access that the first one had. Next, we have contributor. Despite the quite, let's say, modest name, a contributor is actually the default administrative role. A contributor has all create, read, update, delete access in the Azure environment. They can modify any resource, they can create any size of a virtual machine, they can create any type of Azure environment, any service, containers, serverless, anything. They can create it all, they can modify it all. Owner can do that too, but contributor is essentially an owner minus the access management privileges. If you want to have a project manager who will have the privileges to actually assign new contributor rights, then you should use this built-in user access administrator, quite a mouthful, but still a very meaningful role, which is the owner role minus the contributor roles means of modifying the actual Azure resources. So it makes sense to separate the duties of the owner into contributors, which are essentially all developers or admins who actually need to make changes into your Azure environment, and then user access admins who then will be the actual governors or owners, quote unquote, of the actual access management, who is able to log in here at all. And then there is this interestingly named reader role, which actually does not give you access to read data. It doesn't let you log into databases. It doesn't let you read any data within an Azure blob storage. It lets you read the meta information about your Azure services. You can go in and see what is the name of your virtual machine. You can go in and see some configurations, but it doesn't let you access to the data layer. Speaking of data layer, I mentioned that contributor is actually a role that does not grant you access to manage access or control access policies for other users. That's not true when we talk about these database services or platform as a service components that can host data. For example, Azure SQL database, evergreen, almost software as a service like service for hosting SQL databases, Azure Blob Storage, or even Azure Key Vault, which is a location for storing our secrets and certificates and keys. So most inherently should be something that is very secure. All of these services that I listed here actually are manageable with a contributor or all of the access to those services is manageable with a contributor. If I am now following this pattern of limiting my access for my developers from owner to a contributor, I'm still left with the possibility of this contributor going in and modifying who is the owner or who is the main admin of a SQL server, a SQL database. I'm still left with the contributor being able to go in and fetch the main credentials, main access keys for our storage account. And after that, if they leak or those leak, then everything is lost. If I get my hands on those credentials, I can do anything. I can create, delete any sort of data. I can pump more data into, do that denial of wallet attack. And there's no way of proving who is using that key. And then finally, as a contributor, I can go in and make changes in regards to the access policies of a key vault. I can make changes about who is able to create, read, and modify any of my most secret data, my certificates, my encryption keys, and even if I still have some password type of credentials that I store in this trusted centralized repository, even to those. So what to use instead of a contributor? Well, most services offer service-specific or resource-specific roles. So beyond these 4 Azure built-in roles that I described, there's almost 200 built-in roles. There is a storage blob data contributor. There's a storage blob data owner, which grants you access to do anything within the storage blob account, but it doesn't let you grant access to others. So you need to go slightly more granular on that work. And there's tons of other authentication considerations as well. One of them, or the main one, being really this link towards our existing management processes. As I mentioned, contributors, owners, user access admins, all of those can actually have their own kind of shadow IT type of approaches to identity management. They can invite anyone in, they can grant access to people who are not even onboarded as proper users with our Active Directory. They can sometimes create these shadow credentials altogether. And this trusted Azure AD identity can be, and in most cases should be, the same Azure Active Directory that is synchronized from our on-premises Active Directory. So we will use the same username and password to log in. But in some cases, it makes sense to actually have a separate domain altogether, just like we would have a separate AD forest altogether for privileged access. In some cases, we want to onboard all of our users, all of our partner users who work for us, actually as internal users. So we'll invite them in, create Active Directory users in our on-premises, and then synchronize those into the cloud to be used. But in some orgs, it makes perfectly sense to actually trust those partners with actually managing their own credentials. So we can use this Azure AD business-to-business guest feature to invite people from other trusted identity providers or other Active Directories as well. By default, that's something that's available for everyone, so it's federation to everybody, and that's something that you should consider locking down or making a conscious decision there. And there's other access control considerations as well. What happens if the synchronization between my on-prem and cloud fails? Do I have something virtual machine-based version of my AD synchronized to the cloud? Do I have some cloud-only break the glass accounts? Do I have some sort of central accounts that have maybe owner access to each of our environments anyway for compliance monitoring, or just kind of break the glass for the actual users type of experience as well? And quite often I face this when organizations go from this very let's say decentralized way of developing all of this fancy new stuff on Azure, and they start locking things down quite often they start looking at this continuous deployment or DevOps access. What is the user they're using? What is the service principal they're using to actually deploy all of those services with some infrastructure as code? What privileges does that user have? Does that authenticate using a password, username password type of combination? Is there certificate-based authentication and so forth? And that brings me to the last of these points, which is the amount of the Azure AD roles. The Azure Active Directory is always there in the present, and by default, every developer, every user, just a regular user in Azure AD can invite anyone in for access control purposes. Every user can create application registration, so they can create these system accounts. These are the things that we might want to look at actually locking down, so that you'll need to have a specific Azure Active Directory role. There's plenty of built-in roles such as Azure AD application developer, application owner, etc., that you can use to actually grant access to those users who should grant new users for authentication or continuous development purposes. So moving on from identity to data protection. And data protection in Azure, that part that's specifically related to Azure, is really about using the capabilities and understanding the capabilities of what is Microsoft's responsibility and what is still left up to us, and where do we have our options of having extra control, and where do we maybe need to take a conscious risk of using a very highly productive service to our developers with different type of data protection that we used to, or when do we maybe defer from using some of those function as a service type of services, for example, if they don't provide us the data protection capabilities. So first of all, we have the Azure Storage service, the most common service, the one that was it has been available from 2008, always there, just binary large object, cloud native applications storing any type of binary data. Well, all data is encrypted in the storage service layer using Microsoft managed keys by default. And Microsoft guarantees, and now this is something that you'll need to do your due diligence and go in and check those service trust portals, but Microsoft guarantees that data will remain within the data geopolitical region that you choose. You don't necessarily need to have any additional controls to mitigate that. And Microsoft also guarantees some availability functionality there. So Microsoft maintains at least 3 synchronous copies of any bit that you store in Azure Storage within the same data center region. Those might be within the same data center building as well, or they could be a short drive away from each other. So there is definitely going to be a little bit more latency compared to just duplicated storage within the same rack. So you'll need to take those things into consideration as well, as everything is software defined, including the storage and protection of the data within that storage. And we don't have access to the raw disks ourselves, but we have access to detailed activity logs that are available, but we need to turn those on. By default, there is anonymous access available for storage account for read-only access. It makes sense if we are building. It makes sense if we are building services that are hosting public web applications. It makes sense that our binary data is available for anonymous access, but I would strongly suggest that you opt into logging that access as well, so that you know who is actually accessing your data and where. That is something that you consciously need to come in, even though Microsoft provides that option. That's something that adds you extra storage costs, but it also adds you it's something that you need to turn on. So it's operational overhead, and it's something that you also most likely need to prove to your auditor through your compliance functions as well. Very briefly, there was a question on having synchronization across different regions. Yes, Azure Storage does provide that option, that functionality, and other Azure database services as well. The pricing is different for each of them, and the methodology. But for Azure Storage, essentially the most geographically distributed, or the other end of the spectrum will be to having this geo-available, read-available geo-redundant storage that is replicated across data center regions within the same geopolitical area. And you will have 3 synchronous copies in your home data center region, and then you will have 3 asynchronous copies in that other data center region. All of your same functionality that you have configured for network access control or logging or authentication, who has access to that storage account, all of that stays the same. It's one Azure resource that has just 2 different endpoints for your applications to consume. And I mentioned that storage account actually encrypts all data by default using Microsoft managed keys. But what if we want to use our own keys so that we can have control of the key size, or if you don't quite trust our cloud provider, we can be sure that even if in support cases Microsoft wouldn't have access to our data, then we can use Azure Key Vault. And I already mentioned earlier briefly about Azure Key Vault, that it's a solution that stores, controls access, and audits secret, so passwords or any type of text, encryption keys, and certificates. And it's always integrated with our Azure Active Directory tenant. So you always need to first be able to authenticate as a user or service principal or managed identity, and then you need to also have this access policy so that you can actually read the encryption keys in Azure Key Vault. So once you have that set up, you can actually encrypt data addressed in all cloud native services that we have. So we have Azure App Service, we have Azure Disk Encryption for virtual machines, SQL database, storage account, Event Hub. Most most highly used Azure services that store data for a longer period of time already support or have committed to fully support encryption at rest with bring your own key approach in the future. Very briefly, there are a couple of different approaches here. So first of all, the default option that's available for most Azure services is using the Microsoft managed keys. Then if we have existing considerations from compliance point of view about how often the keys need to be rotated, that type of stuff, or what is the key length, then we'll need to go and dig into Microsoft documentation. If we want to control that on our own, using our own processes, we can have a look at this customer managed keys option, where you see that essentially we will store the keys in Azure Key Vault, and then we'll add some automation to rotate those keys. But there's also an option to go beyond the Azure Key Vault, and that will be this customer provided keys. Now, this is available in a very small subset of Azure services. There's no support for Azure Database, for example. There's mostly for small parts of Azure Azure Storage where this is available. But this means that we could hold our keys outside of the whole Azure platform. This could be in on-premises. This could be a HashiCorp Vault or any other service that we would hold and control all our own. So this was encryption at rest. Well, encryption in transit is slightly easier. Again, of course, certificate management is something that we'll need to handle with Key Vault or existing processes. But connecting our traditional network traffic into Azure virtual networks is done via Azure Virtual Private Networks. that allow you to download the individual client to your computers. There's Mac support, there's Windows support, and this is what we call point-to-site VPN. This will be secured through essentially SSL tunnel. Or we can set up site-to-site VPN between our infrastructure on our on-premises network and the network in Azure Cloud. If you want to grant access in the application level, we can have a look at Azure Application Gateway that provides end-to-end SSL capabilities, that provides SSL termination for optimization purposes if needed. And there's other services depending on your requirements. There's a reverse proxy for Azure Active Directory, App Proxy, and others. And lastly, some words about Azure monitoring as well. I mentioned that there's a lot of new information, a lot of noise available, and typically we have even more access to logs that we didn't have in an on-premises world, just simply because everything is behind an API. We don't have blinking lights, or we don't have physical noise of the data center, or all of the fans and appliances being on. We have input from REST APIs. So we'll need to consume that somehow. And I'll have a look at some of those in more detail. But first of all, something that I recommend for everyone, regardless of which Azure service you are using, is the Azure Service Health. Azure Service Health is a service that provides you information about the services in that specific Azure region that you're using. So you can get alerts such as this one, which is a real alert that I got last year from a service incident being active in an environment that I was using, not necessarily my environment, but something that could, if this will turn into a more ugly one, this could affect my performance as well. So there's hourly updates available for me. There's email, ServiceNow, Teams, webhook, all types of integrations for consuming these service health alert data. But in the end, this answers the question that, is it just me, or is the whole Azure down? And this is something that the data is there, but if you don't set up the alerts now, then when something is really down, then you're not able to log into Azure portal to actually go ahead and see that data. There's a public version of Azure Health Dashboard available as well, but incidents are reported there only if they have global impact. So they need to be very widely impacting customer environments in order to be upgraded from this service health into the publicly available Azure Health Dashboard. Beyond these availability related incidents or alerts, we also have something that Microsoft calls advanced threat protection. The idea is that for most Azure data services and for most Azure quote unquote compute services, Microsoft offers the way of turning on the logs, such as for Azure Storage. I mentioned that our audit logs are not on by default. When you turn those on, you actually end up having a lot of noise. You can actually let Microsoft consume those logs for you using quote unquote machine learning and get these automated alerts. There's maybe 20 different scenarios available. So most common scenarios, here's a good example. Someone has signed into your storage account from an unusual location using a Mozilla Firefox and coming from Kuusankoski, Finland, which is, Finland is in the middle of nowhere, and Kuusankoski is, even from Finnish point of view, in the middle of nowhere. So really this is something unusual that I might want to have a look at. There's some potential causes, there's some remediation steps. Very good alert that's kind of ready-made and parsed for me. Instead of parsing all of the raw data myself, I can have my analysts looking at these and validating these instead of the whole raw data. Then we have the Azure activity logs that are, again, such as just like the service health logs, activity logs are available for anything that we do in Azure. So they're the lowest level log of anything that we do, creating a new Azure resource, creating, making scalability changes and so forth. Azure activity logs are there, always available for us for the past 3 months. So you should maybe go in and download some of those logs, export those during that time frame. Most attackers or most intruders have been in for a longer period of time. So in terms of forensics, you will need some place to store that data. But you should be aware of the noise level as well. Here's a quick example from production. This is actually from one environment only. Not highly sophisticated, but a medium complexity. There were some event hubs. There were some different tiers of compute. There's some databases, and without any active development, without anything actively happening, just from auto scaling and other types of events, we got quite a big amount of weekly log information. So you would want to have some sort of automated or manual alerting based on these as well. You can build your custom activity log alerts. So if you recognize that there's a specific activity event that you always want to be alerted for, you can build that. I have some examples here: Kubernetes cluster credentials, Key Vault access policy changes, things that a contributor can do but really shouldn't. These are things that you should maybe build your custom activity log alerts on. Or you can go to the Azure Security Center and just turn on the paid versions of the advanced threat protection, and then you'll get these across not just Azure Storage account, but other services as well. And you'll see there's some pretty nice scenarios here. There's even when you have virtual machines in Azure, and if you consume those VM logs into Security Center, you can put enable advanced threat protection, and you'll get Windows event log clear type of alerts. Somebody cleared them. You'll need to go and see what's up. SSH password spray, unusual amount of data extracted, unusual activity, and so forth. Very highly, let's say, mature alerts that we get here out of the box. So we don't need to define everything as our own custom alert. And I mentioned audit logging earlier. I mentioned that for Key Vault. I mentioned that for storage. Just to reiterate, you really should go in to your storage and security functionality and enable those audit logging. It's not on by default, mainly because it also creates a cost. All data egress and data storage has additional cost in the cloud. But really, if you're using Azure Key Vault, if you're using Web Application Firewall or Azure Storage, you should definitely go in and enable those logs. And it just happens that it's hidden in an interesting location. It's called Diagnostic Settings, and underneath there, you can enable the logs. And there's this whole debate on should you have a distributed or centralized log storage strategy. I don't really care as long as you store those somewhere. Because yes, the default configuration for even these security services that are built in is most often non-existent. Some additional information. There's quite nice, and I think every other year updated white paper developing secure applications on Azure. I really recommend reading this. This is quite light reading in terms of easily consumable for developers or general architects as well. Not that much security jargon. In the Azure documentation, docs.microsoft.com, you'll find Introduction to Azure Security. I prefer to read this as it is, but technically you could go in and download the whole docs site as well. It's a couple of 100 pages altogether. It covers all of these shared responsibility models that I showed you. It covers the Microsoft approaches. It covers some best practice recommendations on how to set up your own security operations in Azure. And lastly, for the security experts in the house, I really recommend the 7 key principles of cloud security and privacy. This is again a white paper by Microsoft, and this is really helping to provide guidance on securing your Azure environments. And with that, we are at our allotted time. We covered a brief overview of the different threats and risks related to our Azure environments, all across infrastructure, platform as a service, and software as a service. We covered identity and access management. We quickly touched upon data protection and monitoring topics on Azure. I'm still here for as long as you are. So if you have any questions, feel free to drop those here in the IM. And I look forward to welcoming you. Is it even next week when we have our next talk in this 4-part series? And if you missed something, or if you want to pause and go deeper, then this recording will be available in a couple of days. With that, thank you very much. And if you have any questions, feel free to drop those here in the IM.